In this video, we're going to learn how to calculate the molarity of leftover ions in a solution where a precipitation reaction occurs. Now, this kind of problem is longer in nature, and if you follow a similar procedure to what this video offers, you should be able to get the correct answer every time. So in this problem, it wants you to determine the concentration of all ions left in solution when mixing 0.100 liters of 0.250 molar of lithium carbonate, and this is added to a 0.250 liters of 0.130 molar of strontium chloride. Now, you are given the balanced equation. Sometimes you're not, so you're required to write it. And we have, in this particular problem, we need to write the balanced equation. This is given to us, the total ionic equation and the net ionic equation. Now, from each of these equations, we're getting different information. So from the balanced chemical equation, I am getting the stoichiometric coefficients, which are important. Okay, so for example, for every mole of lithium carbonate reacting, we get 2 moles of lithium chloride, etc. Now, we need to write the total ionic equation. And why do we need to write the total ionic equation? To be able to determine our spectator ion. So let's write it together. So starting with the total ionic equation. So we have here 2 lithiums. I'm just going to make some room for myself here. Plus carbonate plus strontium ions plus 2 chloride will give me strontium carbonate. Know that this is a solid, so will not dissociate, plus 2 lithium plus ions plus 2 chloride ions. Now, let's highlight where do we think our spectators. Now, again, spectators will hang in solutions. They do not participate in our chemical reactions, and they should be present on both sides of the total ionic equation. Now, so we can see here that lithium is a spectator in addition to the chloride. So we can keep a tally up here of what our spectator ions are. And so we can say that lithium and chloride are spectator ions. And we need also to write the net ionic equation. What information we need to get from the net ionic equation, we will get or be able to determine the limiting and the excess reactant. So the limiting reactant will not be present in solution because it's going to be consumed. So its concentration is going to be 0. And the excess, we will calculate it as we've been calculating it all along this chapter. So from our net ionic equation, so this is the net ionic equation, we have carbonate plus strontium ions will give me 1 mole of strontium carbonate solid. Okay, so now we need to determine which one of these will be left over and which one will be limiting. Okay, now let's start with the easier portion, is calculating the molarity of the spectator ions, lithium and chloride. So lithium, the source of it is lithium carbonate, and the source of strontium chloride is, the source of chloride is strontium chloride. So and we can determine the concentration of these ions left over from the initial concentrations given to me in the question right here. Okay, so starting with molarity. So I can first start with calculating the moles of lithium ions, okay, which should be 0.100 liters times 0.250 molar or moles of lithium carbonate over 1 liter. And now we're going to use the relationship between the number of moles of lithium in 1 formula unit of lithium carbonate. So we have 2 lithium ions in 1 mole of lithium carbonate. Okay, so we have here the moles. Let's check everything checks out. And we have here 0.0500 moles of lithium ions. Okay. Now note that we are mixing 2 solutions of 2 different volumes. So this becomes a dilution problem as well. And in this case, we will have to recalculate the volume in order to get the correct molarity. So the second step is I'm going to say that the molarity of lithium ions left over will be the 0.0500 moles of lithium ions divided by the 0.100 plus the, and these again are given to me in the question, 2.50 liters. And in this case, I get 0.1428571429 molar. And I will go here by 3 sig figs, which is 0.143 molar. So in this case, I calculated the molarity of the lithium ions. Now, we'll do the same exact procedure for the molarity of the chloride ion. So let me clear the screen here, and let's start by doing the same thing for the chloride ions. So for chloride ions, again, I have here 0.250 liters times 0.130 moles of strontium chloride in 1 liter of solution, and then 2 moles of chloride in ions, 2 moles of chloride ions in 1 mole strontium chloride. Okay, and the moles right here are 0.0650 moles of chloride ions. And to recalculate the molarity, so I can say that the molarity right here of chloride ions left over is going to be the 0.0650 moles chloride ions divided by the total volume of both solutions, which is 0.100 plus 0.250 liters. And this should give me 0.186 molar chloride ions. Now we have done these ions, which are the spectator ions. Now it's time for us to calculate the limiting and excess, or determine what is the limiting, and it will be 0. And then the excess, we'll have to calculate the molarity of it. So we need to ask ourselves, what should we do to determine the limiting and the excess? And we will choose in this case, or I chose in this case, to calculate the moles of strontium carbonate produced from lithium carbonate and strontium chloride, and whatever is going to be left or excess, we can base our calculations on. As a reminder, we have already determined that lithium and chloride are the spectators. So in this case, I am looking at carbonate or strontium as my limiting or excess. So let's start with first calculating the moles of strontium carbonate from lithium carbonate. And in this case, I can say that 0.100 liters times 0.250 moles of lithium carbonate in 1 liter. And then for every mole of strontium carbonate produced, we have 1 mole of lithium carbonate consumed. And I have here 0.0250 moles of strontium carbonate. Okay, now I'll do the same procedure. So I can say moles of strontium carbonate from strontium chloride. And I'll do the same procedure, 0.250 liters given in the question, times the 0.130 moles of strontium chloride in 1 liter, times the, for every mole of strontium carbonate produced, I have 1 mole of strontium chloride consumed, and I get here 0.0325 moles of strontium carbonate. Now, looking at the results right here, I can tell that in this case, lithium carbonate is going to be my limiting, and strontium chloride is going to be the leftover. And in this case, I can also make the conclusion that the molarity or the concentration of carbonate ions, okay, is going to be, so these brackets indicate moles over liters, okay, equals to 0.00 molar in concentration, okay, or 0 molar, that'll be fine too. And now I need to determine the excess strontium ion that is left over. So let's move to the last slide right here, and we will again perform the same procedure to determine how much of the strontium ion is left. So the first thing is we need to determine the moles of strontium chloride consumed by lithium carbonate. This is the first thing we're going to do. So in this case, we're starting with the lithium carbonate. So I can say 0.100 liters times 0.250 moles of lithium carbonate in 1 liter, times, we have here, for every 1 mole strontium chloride consumed, we have also 1 mole of lithium carbonate also consumed. And in this case, let's calculate, what do we get? 1.00 times 0.250, and we have here 0.0250 moles of strontium chloride consumed. Now we need to subtract this, okay, from the initial amount in the question given to me, which is this guy over here. So I can calculate and I can say initial moles. I think did I already calculate that in the question? Oh, let's calculate it again. So we can say that I have 0.250 liters times 0.130 moles of strontium chloride in 1 liter. And I'm calculating it with you in real time. And I have here 0.0325 moles. And in this case, I'm going to take this number, okay, and subtract this number from it. So moles of strontium chloride left over will be the 0.0325 moles minus the 0.0250 moles. And this should give me 0.0075 moles, okay? Now it wants us to calculate the molarity. I'll continue on this slide. So we have here the molarity of strontium ions left over. And in this case, I'm going to do what I did. I'm going to take the 0.0075 moles of strontium ions, okay? Or this is strontium chloride. I made a mistake. I apologize. I'm going to take the 0.0075 moles of strontium chloride. And I'm going to say that for every mole of strontium, there's 1 mole of strontium chloride present in every 1 mole of strontium chloride. And this also gives me 0.0075 moles of strontium ions. And lastly, the concentration of strontium ion in moles per liters is going to be the 0.0075 moles strontium ions divided by the total volume, which is 0.100 plus 0.250 liters. And I get here 0.0214285743 molar. And if I'm going to round everything to 3 sig figs, it becomes 0.0021